day everyone, I am Keter Graida, ID123, and today I will be teaching you I'll be teaching you FNDMATH LQ4 problem number 5. So we've already dealt with this type of problem before in our problem number 4. So if you haven't watched that video, I highly suggest you watch that video. So for this type of problem, we have also another obtuse triangle. So we have learned from the previous video that the law of sines states that 10 over sine b is equal to 12 over sine a. Sorry for the miss. I can just arrange this in a more senseful manner, but it works. It's just an equation, so I can just arrange it in any way I want. So equal to 20 over sine c. Well, if we try to solve this, well, we can't, because this is a type of a side, what you call a side triangle, which is inapplicable for the law of sines, because technically you can't cross multiply, or you can't solve for any of the values of b, a, or c. So what we're going to do here is apply the law of cosines, right? The law of cosines. So that's the trick. If you can't solve the triangle using the law of sines, try to use the law of cosines. If it doesn't still work, and it means that there is no solution for that type of obtuse triangle. So the law of cosines state that a side of, let's say, c squared is equal to a squared plus b squared minus twice the product of the two remaining sides, so 2ab times cosine of the angle between the two remaining sides, the angle of between a and b. So the angle between a and b is this one, the one I highlighted in red. So this is just the angle of c. So if you can see, none of these equations bear any. We can't manipulate technically to get a theta, but we can derive it from c. How do we do it? Well, we can just put all the other terms in the other side. Minus b squared is equal to cosine, over b, negative 2ab is equal to cosine of c, right? So in order to remove the cosine, we'll simply just have to multiply it by arc cosine, right? So c squared minus a squared minus b squared over, over, let's put the parenthesis here, 2ab is equal to simply c, right? So plugging in the equations, we could get cosine of negative, arc cosine of what, c squared, it's 20 squared minus 12 squared minus 10 squared over negative 2 times 12 times 10 is equal to c. Moving on to the reflexive property of antisymmetry, we get, well, just bear with me for a second, I will try to input this in my calculator. So the angle of c would be 130.54 degrees. Okay, so the angle, we could write it here as c is just equal to 130.54 degrees. Now let's try. We can try to solve for any angle. We can try to solve for angle A, for angle B. Let's try angle A, right? Angle A. To solve for angle A, since you already know that the angle of C is just 30.54, we could rewrite this equation as cross multiplying these two, we can get 12 times sine of 130.54 over sine of, over 20 is equal to sine A. So in order to isolate A, we can just multiply it by the inverse sine, arc sine of 130.54 is equal to A over 20, right? Might seem a little bit convoluted. 0.54 over 20, and that would get us the answer of 27.12 degrees. So A is just equal to 27.12 degrees. So you can try to do the similar method here by cross multiplying sine B. So sine B would be equal to simply sine 10 sine of 27.12 over 12. So we just cross multiplied, or simply using the rule of interior angles, since we know that the sum of the sides of a triangle is just equal to 180. We could say that B is just equal to 180 minus the sum of 130.54 plus 27.12. So we get 22.33. Okay, so we get 22.33. So it may not equal up to 180, but that's because we left out some decimals, so there's a little bit of margin of error. Well, so technically that's it. We've already solved for all the angles. So in order to check, the ratios must be all equal to each other. So 10 over sine B, or 10 over sine 22.33. That gets us 26.32. So 26.32, 12 over sine 27.12, 26.32 also, and 20 over sine C, that gets us sine 130.54, 26.32 also. So yeah, that just proves that our given angles are correct. So if you want to double check whether or not you've got the right answer, you can just use this. Yeah, you can compare the ratios of the angle of the sides and the angles. All right, so that is all. Thank you for watching, and I hope you've learned something new today. Thank you, and I hope to see you on the next video. You can scan the QR code to book for more tutorials.